Hello again. We are on episode 7 of our awesome series on web service design and web service standards and all sorts of googlies related to web services. So, thank you for watching the first 6 episodes. We are here together for the 7th again. Now, this episode will be entirely dedicated to one particular topic, and it is surprising that this topic is not more widely discussed in web service or server-side application or browser-based application design. Okay? This is a topic which impacts most large business applications, pretty much every large business application that we've worked on. Now, what is that? To be able to understand this, let us understand what a web service does. A web service receives a request from some so-called front end or so-called client. So the request comes in. There is a little bit of code that is triggered on the server. It does its job. It does its data crunching. It either writes things to the database or pulls things out of a database, and then it sends a response back. That's it, right? The entire web service typically takes less than a second. Let us assume that there are some web services which take time, which will take 5 seconds, 15 seconds. But that's about it. In the world of web services, it is infeasible to have a web service call taking 5 minutes. But in the world of data, in the world of business applications which generate large MIS reports, a report can easily take 12 hours. In the world of business applications, every once in a while, we encounter complex MIS reports which take 12 hours to generate, and I'm not joking. Okay. So what happens then? Even if we don't take the extreme case of 12 hours, what happens when a report takes 12 minutes? How do you make a web service call, trigger a report generation, and hope to get the data out in 10 seconds when the report itself is going to take several minutes to generate? This is a standard problem, but we don't seem to find standard answers. So every design team, every large business application development team have cooked up their own recipe for solving this problem. We too have done something. We not only have a standard approach to solving this, we also have code in our framework. We use a framework for web service based, browser based application development. This framework is open source. It is available in 2 programming languages, Java and Go. There may be a third programming language added someday, but we do not expect it in the near future. So if you are working with Java, Spring Boot or Go and Gin, then you can pick up our framework and just implement some of these things which we are talking about in this talk. But even if you don't, let us see what we do, what is our approach to solving this problem. So we call this category of problems slow reports, slow queries or slow reports. What is the basic idea? Okay, the most basic idea is the front end makes a request to the server and the server queues it. The server does not attempt to execute it then and there. And then the server responds to the front end, which means the web service call immediately responds back saying, your request has been queued, come back later. The front end then keeps polling the server, has my report been done? Has my report been done? Maybe every 30 seconds. When the server has finished doing the processing, it gives a response back to the front end. If necessary, if the data is of a very large size and cannot be loaded into one web service response, then the server-side code will split the data into pieces, and then the front end can pick up one piece at a time. Okay. So this is basically what it is. This is the whole idea of a slow report. The request comes in, it gets queued, the front end is told, your request has been queued, come back later. Then the front end keeps coming back over and over. Has it been done? Has it been done? Has it been done? When it has been done, the server will respond back saying, here is the data, it's been done. So this is an example of the first response when the front end makes the web service call and the server responds. Look at the response. The response says, this is your report ID. There is a UUID string that you can see. That is a unique ID. So the server responds to the caller saying, your request has been queued, your call is successful, this is the ID, this is like a token, please take it and keep it with you, come back later. And try later is true. So try later is set to true. Now after the processing has been done, after that if the front end or the caller calls the server back, every time the caller calls the server, it calls it with a report ID. The first time that a new report is being requested, there is no report ID in the request. The second time onwards, the request carries the report ID which was given to it after the first request. So now the front end makes a call saying, is it done, is it done? And the server now says, yes, it is done. And now look at what the response contains. It contains the same report ID. It specifies a part number. So this is a case where the report is so large that it is going to be returned in multiple parts. It specifies a part number. It specifies the total number of parts. And it gives the data of the first part. So here the front end is getting one part out of 5 parts of the result. When the front end wishes to ask for the second part, it makes the same call again and it submits the same report ID again, but it also specifies a part number. So this is the request. This request tells the web service that the front end is asking for the second part of a multi-part report. Now what if the report required only a count? What if the front end only wanted to know the count and not the actual data? In that case, the volume of data will be extremely small, but the report will still take several minutes to generate because the report was complex. The report generation time does not depend on just the amount of data alone. It also depends on the amount of I/O that has to be done in the database to generate the final result. So in a situation where the caller wanted only the count only would have been set to true in the request, and the response, whenever the response is ready, the response will carry a count. So that sort of closes the whole chapter of slow reports. Okay. Now we need to understand how to implement this. What actually happens below the surface? We have explained the interface. Now let's look at the implementation. There is only one web service call required. That web service is called over and over again, but there is only one web service which is involved in implementing this. The first time that the web service is called, it responds with a report ID and try later is set to true. The second time the web service is called, it will be called with the report ID. The response will go back with the report ID and try later equal to true. This means that the report is not ready. So the caller keeps calling the same web service over and over again, submitting the report ID and hoping for a result, and each time the web service returns saying try later, try later, try later. Finally, in our example, on the 15th round, the web service says report is ready. So it actually returns the actual data of part 1 by n, which means if there are 12 parts, then the first out of 12 parts is returned. The next call, the next part is returned, and so on and so forth. So this is basically the calling sequence which implements our slow reports interface. This is already implemented and ready to use for you in our framework called Alia. So the Remiges Alia framework already implements slow reports. Now the call request, the request that comes in from the caller to the web service, if it does not contain a report ID, it means a new request is being placed. If it contains a report ID, then the other parameters don't matter, they are ignored, and it means that the caller is simply polling for the status of an existing request. So this is how the web service knows whether this is a polling request for an existing polling call for an existing request, or it is a new request which is being placed. One of the important things here is to make sure that callers don't misbehave, the calling code or the front end doesn't misbehave. The web service needs to do rate throttling, because as it is, the pattern of calls tells the front end that the front end needs to keep polling. And if the front end is not written in an intelligent way, it will keep polling every second. Now that sort of polling is just going to add load to the server for no reason at all. It does not benefit anybody. So there should be rate throttling implemented such that if the calls are coming too frequently from a particular calling IP address, then the web service will return saying try later without even looking up the report ID to see whether the report is ready or not. Now, we have talked about the interface, we've talked about the call interface, we've talked about how the front end and the server interact with each other. Now let's look at what does the web service do. So for this, we use an object store. We don't like to use file systems anymore, they are more error prone. So each part of the report is stored in an object store on the server side. So we use various open source object stores. We are very fond of MinIO and Ceph. So we use these object stores for our applications. Each part of the report is an object. Okay. An object store, if in case you're not familiar with the idea, an object store is like AWS S3. It's not a file system. You can store a bag of bytes as an object in an object store. So an object is conceptually similar to a file, but an object store is managed differently and it is far more suitable for programmatic use than a file system. When the front end makes a call and the web service understands that there is data which needs to be returned, it pulls out the data from the object in the object store, it encodes using base 64 and sends it back. And periodically stale objects will need to be purged. So this object store provides us a storage foundation for implementing these deferred reports. It is possible to implement the same thing without an object store using a file system, but we find it easier to use an object store because then we don't have to map files. In the containerized world of today, an object store provides a web service interface, which is easier for my web service code to make. It makes an REST API call to the object store instead of actually writing files using file system IO calls. The whole thing is far more suitable for the modern infrastructure, modern architectures than a file system. But you can definitely implement this without using an object store if you prefer. The next possibility with a slow report is, what if the caller does not want the result in the response of a web service, it wants the result in the form of a file. Now, in that case, we have worked on many legacy business applications where file transfers are the way for transferring large amounts of data. So actually SSH, SCP are used for file transfer. What if that kind of a scenario exists in your case? In that case, instead of storing the file in parts in an object store, you store the whole output data in one large file on the file system. So you basically store the files in a separate area which can then be accessed by the other party. Okay, so the other party, the calling party, can either pull it out using a file transfer server, or you can build a wrapper on top of an object store where when the party wants to pull out that file, the file is pulled out from object store and then handed over as a file in a file system, whatever it is. So you build an interface between your object store and a file system. So do not use the local file system of your web service code to store these temporary files. This destabilizes your server. So if you need to store the resulting report in a file, have a separate file system just for this temporary storage. So as a web service designer, what do you spec? What is it that you need to write? Assuming that you have a framework like Remiji's Alia, or if you don't have a framework, if you don't have Alia, build your own framework, but that part is reusable code. So for each slow report, you need to add small amounts of code. One small web service call. one worker function which will actually generate the report. So there is really very little additional coding to learn or write if you implement slow reports using our approach. You write one worker function and one small web service call. This code was unavoidable. It is not extra code. You write the code to generate a large report in any form, on any framework, in any programming language, you'll still have to write that amount of code. That is all that we are asking you to do in this case, except that the code is split into the web service interface, which does not actually have the business logic, and the worker function, which has the business logic to generate the report. That's all. So we come to the end of episode 7, and we have just seen slow reports. The next episode will continue along the same lines, and we will discuss what to do with big, bad batch files. Batch files are a natural extension to the idea of slow reports. So thank you for watching, and see you in episode 8.